In level 3, we're going to put together everything we learned in level 2. So we're going to be thinking about the end behavior, the zeros and their multiplicity, and then we're going to sketch a graph that looks pretty close to an accurate graph. Okay, so the first thing we should think about is maybe end behavior. Start there. And remember, with end behavior, we have to figure out what the leading term would be, or the term with the greatest power. So if I multiplied the biggest parts of this function, I would get, well, there's a negative in the front. This part has an x as its biggest part. This is going to have an x squared. So my leading term would be negative x to the third power. The end behavior for a negative leading coefficient and an odd power is going to be the same end behavior as y equals negative x. It's going to go up on the left side and down on the right side. So just keep in mind that that's what the ends of the graph are going to do. And then I'm going to think about my zeros. So the numbers that make each part 0, I have negative 1, and that's to the first power, so multiplicity 1, and it's going to cross. And I have a 0 at positive 2, which is multiplicity 2, and it's going to bounce because it's even. So I make x-intercepts at negative 1 and positive 2, and I start with my end behavior. Oh wait, we also have to find the y-intercept. Can't forget the y-intercept. The y-intercept is when x equals 0, so plug in 0, and you get, for x, and you get negative 1 times negative 2 squared, and so that's going to come out to negative 4. So down here at negative 4 is going to be the y-intercept. Now to graph the function, I start with my end behavior where the graph starts. I'm going to start on the left side over here. And the first intercept I'm going to go through is negative 1. So it's going to go down and it crosses through negative 1. Then it's going to pass through this intercept and go up to this 0, 2. This one it has to bounce off of, so it's going to come back down below and then finish pointing down. And there is a basic sketch of the graph with accurate intercepts and accurate end behavior. Okay, in the next example, the end behavior, we're going to look at our leading term, or the term with the biggest power, and so we have 2x to the 4th. This has a positive leading coefficient and an even degree, because it's degree 4. So a positive leading coefficient and even degree is going to have the same end behavior as x squared, like this, so it's going to be going up on both sides. Now to find the zeros, I need to change this to factored form. So I'm going to factor this expression. And first I can factor out a GCF of x squared. So I get, give myself some more room, x squared times 2x squared minus 3x minus 2. And then I'm going to factor this expression. I leave the x squared in front, and I have 2x and x, and then I need a 2 and a 1. I'm going to put the 2 here and the 1 here. That gives me 1x and 4x to give me negative 3x. I want this to be negative, so I put a minus here. I want this positive plus there. Okay, so now that I've factored the expression, I am going to find the zeros. The zeros are, this would just give me 0, and that's going to be multiplicity 2 because it's to the second power, and that's going to bounce because it's an even power, or even multiplicity. My next 0, for that 2x plus 1 to be 0, I solve a little equation. I get 2x equals negative 1, x equals negative 1/2. So negative 1/2 is a 0. And that's raised to the first power, that part, so it's multiplicity 1. And it's going to cross. And then my last 0 is positive 2, which is also multiplicity 1, because it's to the first power, and it will cross, because it's an odd power. And so now I plot my points. Oh, and we also need the y-intercept. The y-intercept is when I plug in 0 for x. And if I plug 0 in for x up here, I'm just going to get 0. So 0, 0 is going to be both an x and y-intercept. And then negative 1/2 and positive 2. Those are my 3 x-intercepts. And so I start with my end behavior. At negative 1/2, it's going to cross, so I go down and cross down below. And then it's going to have to loop back up and go through 0. And that one has multiplicity 2, and it's supposed to bounce. So instead of going up, I'm going to bounce back down and go through this x-intercept, which is supposed to cross. So I cross and go up and finish with my arrow ending up. Okay, here's one more example where we're going to draw a graph. The degree of this function, if we multiply an x squared times an x, we're going to get a third degree function, so degree 3. The y-intercept is what we get when we plug in 0 for x, so we get 3 times 1 squared times negative 3, which comes out to negative 9, or the point 0, negative 9. And the x-intercepts and their multiplicity, this has 2 x-intercepts. One is going to be at negative 1, and that's going to be multiplicity 2 because it's raised to the second power. And even multiplicity bounces. And then our other x-intercept would be positive 3. That's multiplicity 1. And it's an odd multiplicity, so it's going to cross. And then looking at the graphing calculator, you can kind of get the general shape, but you will find that it has a local max at the point negative 1, 0. This is the max. And we already knew about that one because that's actually our x-intercept, but then it also has a min that we wouldn't have been able to find without a calculator at about 1.7, negative 28.4-ish, around there. So that's a point we wouldn't have been able to find without a calculator. Everything else we can do with a calculator. Now we plot all these points, and we also need to determine the end behavior. For the end behavior, the leading term for this function would be 3 times an x squared term times an x, so we would get 3x to the third. This is a positive leading coefficient with an odd degree, degree 3. So that's going to look like y equals x for its end behavior. So it's going to go up on this side and down on this side. And we have to plot the points. So we get an x-intercept at -1 and at 3. And the y-intercept is at -9. Put that about right here. And then we also have a point, this min point that we need to plot, -1.7, -28.4. So maybe down here. Okay. Now if we draw the graph, starting with the end behavior, I start down here on the left side, and I go up through -1. It's supposed to bounce off this x-intercept, so I'm going to bounce and go back down and through the y-intercept and down through this minimum point. And then we go up through the x-intercept 3 where it's supposed to cross, so it keeps going up. And there would be the shape of our graph.